Hello guys, and welcome back to another episode of COVID Chemistry. Today I want to do a nice recap incorporating a lot of information that we've already looked at already. As you can see on the board, we have a lot of content to work through. What I would suggest at the moment is you pause the video right now, you get a piece of paper or your workbook and produce a template that is allowing you to put in a lot of information that we're going to work through today. So I'm just going to step away from the video. You can pause the video now and you can create a template for this. Okay, right, so here we go. Lots of definitions to work through. We're going to follow a nice simple template, taking it one by one with our word and how we can define this. So our first one, using our example that we're looking at, is metal oxide. If we were to open a chemistry dictionary or a scientific dictionary for this, it would tell us that it's a compound formed when a metal ionically bonds to oxygen. Great definition to know, great definition that is going to pick you up several marks within your exam. Okay, now we're going to work through the exercise. The first ones, we have our definitions. We're going to state the keyword that relates to. Then we're going to create some definitions, and then we're going to define some things again, and then you have a challenge at the end. Okay, so next one, the order of elements in terms of their reactivity. Let me just improve this. The order of elements in terms of their reactivity. Hopefully that has triggered something in your mind about sending lions, cats and monkeys to lovely hot countries. Thailand being a lovely hot country at the moment. Yes, correct. That is our reactivity series. So let's write that one in. Oh, not got enough room. I have to write shorthand. So reactivity series. Hopefully you've put that in your table. This is a great little document we can have here. A lot of these words are referred to in various components of the chemistry course. Next one, a substance that releases hydrogen ions and it has a pH less than 7. Okay, pH scales, if you don't have one in front of you, you can find them on Google Images. It's a very simple key stage 3 thing you would have studied. I have one on the board for you to refer to here. pH less than 7, but the key term we want to know for the GCSE chemistry course, that this substance releases hydrogen ions. And we'll get to that a little later on. Correct, so we have an acid. Nice, okay. Just bear with me for one moment. There's some method in the madness here. I'm just going to jump from our next definition a little bit further down because it corresponds to what we've just defined here. Our next one, a substance that releases hydroxide ions. We have an acid, now we have an alkali. Okay, so acid releases hydrogen ions, pH less than 7, okay? Alkali releases hydroxide ions. Let's go back up. So a substance that neutralizes an acid. Neutralization reactions is something that you would have done in class, and the key term we'd like to use in the GCSE course is that we refer to these as a base. We're all about that base. Okay, let's keep going. So we have our key terms. 1, 2, 3, 4, 5. We're close to halfway there. Let's incorporate some information here. So you have your hydrogen ions plus your hydroxide ions. We can identify the release of hydrogen ions from our acid, hydroxide from our alkali. Acid plus alkali is giving us a salt depending on the reactant, and water is released also. Great, we have a neutralization reaction. Let's just write this one in. Oh, we're struggling for room once again. Okay, next one, let's keep going. ionic compounds containing carbon and oxygen. Tricky one, carbonates. 1, 2, 3, 4, 5, 6, 7. We're halfway there. Great, let's keep going. Let's go the other way now. Salt, how can we define this in terms of chemistry? Well, let's go back up. Salt. So a salt is a product of what type of reaction? A neutralization reaction. We can see how everything is combined in here. We can refer back to previous definitions to build everything together. All right, let's keep going. A substance that dissolves. What key term can we identify from this for a substance that dissolves? It begins with S. Hopefully you have it. We can refer to these as being soluble. Nice. If we have something that does dissolve, naturally we're going to have something that does not dissolve. Yes, you can see the pattern here. Here we go. Insoluble. Guys, we nearly made it. We are so close. Next one, indicator. Year 9s used this the other day, doing some great experiments when they were looking at the reactivity series of metals and our group 1 alkali metals reacting with water to prove for the presence of this metal hydroxide alkali-based solution that was produced. They used an indicator, and this showed us how acid or alkali the product was. So what this does, an indicator, it tells us, or it shows us, the presence of I don't have much room here. So test for the presence of an acid or an alkali. So there we have our definitions. At the moment, what I want you to do is just have a recap of the ones we have looked at before we move on to 2 more technical terms. One of them is electrolysis. I have an electrolysis video on my channel. Some of the GCSE students have not studied this yet. Year 9, you have not reached this yet. Year 10s, if you want to go back and do a recap on electrolysis, please do this. But our definition for electrolysis is splitting up ionic compounds using electricity. So if that is something you think, I kind of remember the topic when we did it in class, but I can't remember the details of it, just go back, have a look. But the definition we want to state is a splitting up of ionic compounds using electricity. Okay, lots of great key terms for there so far. Our final one, my challenge to you, is to find a suitable definition that you understand, not just copy and paste it from Wikipedia, for this term molten. What does this term molten actually mean? Okay, so I mentioned that at the start, when we started this video, we'll have reference to this pH scale. Hopefully some of our definitions now allow us to look at certain information here. Hopefully you're looking at this thinking, yeah, that's nice and simple. I did it in year 7 and year 8. But for the GCSE course, we're just going to take our level of knowledge up a little bit more. So let's go back to the start. Let's recap of what we know. So a substance that has a pH between 0 and 3 is a strong acid. And what we can do now, we can refer back to our definitions here to actually state what an acid actually is. A solution with a pH between 4 and 6 is a weak acid. pH 7 is a neutral solution. My year 10s recently did a titration to produce this neutral solution. Great work by them. Going on further, now we're looking at our opposites to our acids. We'll refer to them as our alkalis within this situation. So here we have our weak alkali. And then finally, yes, you guessed it correctly, we have our strong alkaline. Okay. Let's keep going for our knowledge on this pH scale. And what do we need to know? What am I referring to when I talk about a strong acid can fully dissolve? What am I referring to there? Well, when a strong acid is placed in water, we say that it fully dissolves, or keyword, let me put this one on, fully dissociates. A nice term when you get to your A-level chemistry course, you will look at the ionic properties or the ionic products of water involving the dissociation here, okay? Strong acid fully dissociates when placed in water. A weak acid partially, some of it does, some of it does not dissociate or dissolve in water. Weak alkalis, very similar patterns to here. Weak alkalis, they only partially dissolve when placed in water. And our strong alkalis, they fully dissolve, or improve our terminology, and fully dissociate when placed in water. Okay, so a very common example of a strong acid, which you would hear referred to throughout your chemistry courses, is hydrochloric acid. So I'm going to show you a template of how we can demonstrate our understanding of this full dissociation of our strong acid when placed in water. So hydrochloric acid, HCl, made of hydrogen and chlorine. So here we have it. So, dissolved in water. We said we're going to have this full dissociation taking place. So how can we represent this? Well, full dissociation, breaking up taking place here. We're having this is our product like this. So my challenge to you is using this template and a bit of additional research, which we always promote, is to have a look at the partial dissociation of weak acids and weak alkalis. I'll give you a little bit of a tip. We do have a slight change. We have a reversible reaction taking place here. And then identify your full dissociation of a strong alkali. So your template that you're going to follow, we have done our full dissociation for our strong acid. You're going to follow our template. Identify your weak acid, information in here, placed in water, what is produced. Weak alkali, do your research, identify a weak alkali, placed in water, what is going to happen. And our strong alkali, put in water, what is going to happen. Oh, lots of information, let's keep on going. Definitions, right. pH scales, reactivity series of metals. I said everything is going to come back together. We start at one point, we go around, and finally we complete this loop. Reactivity series of metals, the order of elements in terms of their reactivity. Our nice rhyme and our nice poem that we've referred to so many times within our GCSE course, our sending lions, cats, monkeys and zebras. Let's just refer to it once again so you guys have it as reference on this YouTube channel. You can take a screenshot or you can just use your template that you are creating at home to get this down. I'm going to write from this side. I find it difficult writing the other way. So let's go. Reactivity series of metals. We have potassium, and then sodium, and then lithium, and then calcium, and then magnesium. What was that rhyme I was talking about in case you cannot remember? Please send lions, cats, monkeys, and zebras, or zebras if you are in the United States. What's coming next then? Please send lions, cats, monkeys, and zebras into iron, lovely lead, hot hydrogen, You might be at home thinking, but hydrogen isn't a metal. Correct, hydrogen is used for the extraction of some metals, not within our reactivity series of metals, but we still include it in here. So let's go once again. Please send lions, cats, monkeys and zebras into lovely hot countries. Signed, okay? Who is signing this document? Very famous man. General Penguin. And there we go. Our reactivity series of metals, the order of elements in terms of their reactivity. Okay, we can categorize these now. We can split it into 3 different categories, and then we can identify how we actually extract these. So you've probably realized you've done this experiment in class. Our first category, we state that they are highly reactive metals. I hope that's big enough for you so you can see it at home, that's fine. So potassium, sodium, lithium, calcium, magnesium, aluminium, highly reactive metals. Our next one, zinc, iron, lead, hydrogen and copper. We say, or we refer to them as our base metals, okay. And then our general penguin, sign general penguin, we call these our native metals. Wow, lots of information at the moment, okay. Highly reactive metals, base metals and our native metals. Lots of information here. We need to know this, so I hope you are still following. How can we extract these? How can we get these metals? 3 different things we want to be able to identify. You would have done this experiment in the classroom. Potassium, sodium, lithium, calcium, magnesium, aluminium, they can all be extracted through the process of electrolysis. If you haven't studied this yet in your class, if we are still on this school closure and we're starting to go through electrolysis, yes, correct, we can go back to our definitions. Electrolysis, what is it? The splitting up of ionic compounds using electricity. And if you want to do some further study before you do it in the classroom, you can have a look at the video, you can look at the technical things that are happening here. Our base metals, and there is some reason for the madness here. I've not just left a gap. Any base metals, I'm going to place that in here. Carbon, so our base metals, they can be extracted using carbon. And what we're doing, we're heating them with carbon, we're causing a reaction to extract these metals here. This process, quite a strange word, we're heating it with carbon within a process of smelting. A bit like melting with an S on, smelting. And finally, our native metals, our final one we want to look at, they are just found as pure metals. So that's nice and simple. Found as pure metals. They're solid, silver, gold, and platinum. Nice and simple. So lots of information there. Please take your time working through this template. Make sure you're recapping all of the information. Lots of definitions here. What is our definition for this key term molten? Can you find out that? We looked at the dissociation. Water has strong acids, they fully dissociate. Weak acids partially dissociate. Weak alkalis partially dissociate. Strong alkalis fully dissociate. And your challenge, I did challenge number 1 for you. I did my research. Strong acid, hydrochloric acid in water, full dissociation. What is happening with our other things we have here? And finally, we used our key rhymes to identify the categories of these metals and how they can be extracted. There we go, thank you for your time once again. I hope this has been very useful. Please find all reference to any exam papers within the Google Classroom